let's multiply monomials. So a monomial is just a polynomial with one term, okay? But let's not get bogged down with that. This is an example of a monomial, everything inside the parentheses, all right? But what I want to focus on is the rule for this. So if you were with me for the product rule, you'll remember that if we have like bases, which means the same variable, so y and y, okay, ignoring the exponent there, if they're like bases, we can add the exponents. All right, when we have a coefficient, we're going to see that the only thing that's different is now we're going to multiply coefficients as well as add the exponents. So let's try. We have y to the 4 and y2. So like bases mean I can add the exponents. So 4 plus 2 is 6. So y to the 6th. Now you'll see I have y to the 4 and y squared. So we know we're going to do y6 on this one. But now we have a 3 and an 8. Okay, so we're going to do 3 times 8, which is 24. And then we have y4, y2, which is just y6 that we did before. Okay, so we're multiplying coefficients and we're adding exponents. All right, and if you're not sure why we can add those exponents, please look up the product rule. I did one on multiplying like bases, and that will explain why we add the exponents. Okay, let's look here. We've got 4 and 5. So 4 times 5 is 20. So we're going to have 20 here. Now I've got C3 and I have C. Anytime there's no exponent, it's just an exponent of 1. So I'm going to add the exponents. 3 plus 1 is 4. So my variable is C to the 4th power. Okay, we have 6 and 5, which are our coefficients. 6 times 5 is 30. And then our variable is W. We're going to go ahead and put a 1 there. And W to the 4, so 1 plus 4 equals 5. So I have W to the 5. All right, these are going to get progressively more difficult, okay? Hang with me, see if you can follow along. So I'm going to look for my coefficient or my number in front of the variable. I have a 2 here, but I don't have anything here, which means that it's the same as having a 1. Okay, what's 2 times 1? Well, that's just 2. Okay, now let's look at our variables. We have 2. We have x, which is the same as x to the 1, and then y to the 1, x to the 1, and y to the 1. So we want to look at like bases, x and x, all right? If they're like bases, we can add the exponents. 1 plus 1 is 2, so I'm going to write x, 2. And then for my next one, I have y and y. They're like bases, the same variable. So that says I can add the exponents. 1 plus 1 is 2, so I have y squared. Okay, let's look at the next one. 6 and 8 are my coefficients. Those are the numbers in front of the variable. 6 times 8 is 48. Now I'm going to look for my variables. D, I don't have any more D's. So there's nothing for me to simplify or combine. I'm just going to copy the D there. I have M to the 1 and I have M squared. So my rule says I can add exponents. 1 plus 2 is 3, so M to the 3. So my answer is 48, dm cubed. All right, next one, we have 4x and 3y. So 4 times 3 is 12. Now I have x and y. X and y are not like bases, so there's nothing for me to combine. I'm just going to copy them over here. And I have y, so just copy y. So 12xy is my simplified answer. Okay, the next one, we have 8, 3, and then there's nothing here. That's like having a 1. Okay, so 8 times 3 is 24, and 24 times 1 is just 24. All right, 24. Let's do g. G to the 1, g squared, and g3. Okay, so 1 plus 2 is 3, plus 3. 1 plus 2 is 3, 3 plus 3 is 6. So I have g to the 6. Okay, now we've got 7. There's no more coefficients. It's like having a coefficient of 1. 7 times 1 is just 7. All right, now I've got j to the 1 and k, and I have j to the 4 and k again. So I can combine my like terms of j, my like bases, excuse me, not like terms. All right, I'm going to add my exponents. 1 plus 4 is 5. And then I've got k2 and I've got k2 again. So I can add those exponents. So 2 plus 2 is 4, k to the 4. Okay, often I'll see students that feel like they need to combine it all into like one answer, and that's not necessary. If you have different bases, then your answer can have as many different bases or variables as are necessary. 5 and 4, there's nothing there, so it's just like having 1, right? So anything times 1 is itself, so 5 times 1 is 5. 5 times 4 is 20. Now I'm going to look at v. V squared. Any more v terms? No more v terms, so I'm just going to copy v down. And then I've got w squared. I have w to the 1. Okay, I can add exponents here because these are like bases. 2 plus 1 is 3. And then I have one more, which is z. Z to the 6. There's no more z terms to combine, so we just go ahead and copy the z there. All right, so the key to success in these is you multiply coefficients and you add exponents.